Welcome back. This is an Aleks homework video on predicting the qualitative acid-base properties of metal cations. What a scary problem. This would scare me. If this was a problem and I had no idea at all what would happen, it would just panic me. But there are some clues that will probably allow you to do fine at any of these problems. Okay, so just let me give you a couple rule of thumbs. Anytime you have a salt, all these are salts. Anytime you have an ionic compound, it's a salt. And when you put it in water, it's going to dissociate into cations and anions. So if you're going to guess whether something is going to make the water acidic or basic or nothing, then you're really looking at what's going to happen to those anions. Will they become an acid? Can you make those anions into a conjugate acid or not? What about the cations? Will the cations be slightly acidic or not? So there's just a few rules of thumb that might help you get almost all of these. You might miss one occasionally. So let's look at these together. First of all, let's look at the anions. If you have an anion, like this first one is iodine, okay? If you have an iodine, you ask yourself, what does it make if it makes if it joins with hydrogen to make an acid? What type of an acid would it be? So the first thing that I would think of is, okay, there are 7 acids. Okay, if you remember that they're strong, and hydrogen iodide is one of the strong acids. So if it's a strong acid, then that means that its conjugate, your conjugate, the iodine anion, is neither acidic nor basic. Okay, so hope for a compound that makes a strong conjugate acid, because then you know that the iodine does nothing. It doesn't make it acidic, and it doesn't make it basic. So what else? If the conjugate acid is strong, it doesn't do anything. In this case, the iodine wouldn't do anything. So that's the first thing to look at. If it's weak, if the conjugate acid is weak, then it will be slightly basic, because it's going to itself be a weak base. So the conjugate base of a weak acid is a weak base. So that's what I would look at. I would look at the anion, ask myself a question: is its conjugate acid a weak acid? If the conjugate acid is a weak acid, then it itself is a weak base. If its conjugate acid is a strong acid, then itself is nothing at all. So that's the first thing that I would look at. Okay. The second one would be the cation, and the cation is a little bit harder. The easy one would be if you have a group 1 or 2. If you have a group 1 or 2, it's neither acidic nor basic, with the exception of beryllium. I think beryllium might be a little bit acidic because it's so small. What you're looking for is if you have a transition element that has a high oxidation number, so a 2 or a 3 or a 4 or something more, a 5, anything that's big is probably going to be acidic. That's the one thing to look for. Also, in the middle of the transition metals, you're going to have a group of transition metals right there in the middle that are slightly higher. So for instance, 46, 47, no, 44 through 46, which is ruthenium through palladium. Those have high electronegativities, so they will be slightly acidic. And then right underneath them would be 76 through 79, that's osmium through gold. They would be slightly acidic. So really, the rule of thumb, I doubt for a minute that you're going to have any of these as your examples. My guess is that you're going to have really small transition metals, and you're looking for transition metals that have maybe a +2 or a +3, and if you do, they're going to be slightly acidic. Okay, so let's take those rules and see what we can do. So let's look at the first one. Potassium is in group 1, so it does nothing. Iodine is the conjugate base of a strong acid, so it's going to do nothing. So together, that would be neutral. If I can basically go 1 to 1, it's going to be neutral. Sodium cyanide, sodium is in the same boat. It's a group 1, so it's not going to be anything, okay? So the cyanide, you have to ask yourself, what is cyanide? Well, the cyanide, if you were to put HCN, that is a weak acid. And if that is a weak acid, then that means that the cyanide itself is going to be a slight base. So I would write this as basic. Okay, if HCN is slightly acidic, then NaCN would be slightly basic. The last one is aluminum nitrate, and nitric acid is a strong acid, so it itself does nothing. So the nitrate does nothing at all, but the aluminum is Al3+. It's one of these 3+ guys, and because it's 3+, it is going to act acidic, and so it's going to form an acidic one. And again, you're going to have infinite number of examples here, but really just the key idea is you're looking for transition metals with high oxidation numbers, 2s, 3s, 4s, 5s. They will be acidic. You're looking for conjugate acids of that are weak, then its conjugate will be a base. And other than that, just try it again and again. This one might take you a few ones before you can get it right. I hope you're doing well.